3D printing to build roads and habitats and so on the Moon and Mars. There was a small scale funding for that was going on by NASA right now. Related to that, there was a Mars analog, meaning kind of a simulated Mars and space station that was actually being done at Johnson Space Center. I should give you an update on that.
Long term, for sustainable presence on the moon or Mars, we need to be able to build using local materials. It's just too expensive to import building materials from Earth. NASA and the Air Force are funding research to use 3D printing for construction on the moon or Mars. This includes landing pads, blast shields, roads, and habitats. In the foreground of this illustration, you're looking at construction of a landing pad on the moon. This ensures a flat, stable surface for safely landing spacecraft, and also reduces the amount of dust thrown up during takeoffs and landings. This matters because lunar dust in particular is like tiny shards of glass, very tough on materials and people. The vision here uses autonomous robots. At the end of a robot arm, there's a laser or other equipment that melts regolith, the dirt, fusing it together to make what are essentially interlocking bricks. Other robots are shown building a road to the landing pad. Off in the distance, there are robots creating buildings or other structures. This illustration suggests that building roads on the moon has something in common with highway construction on Earth. Here we have more highway department employees standing around watching the work get done than people actually doing the work. NASA and the Air Force have awarded an SBIR Phase 3 contract to Icon, which is an Austin based company that is already building houses on Earth using 3D printing. The contract is for $57 million. SBIR stands for Small Business Innovation Research, which is a form of funding long used by a lot of federal government agencies for research by small businesses. Typically, the funding for the phases starts small and then grows with subsequent phases. Icon previously 3D printed a structure called the Mars Dune Alpha at the Johnson Space Center. That's a Mars based analog for simulating operations on a Mars station. The simulated Mars missions is called CHAPEA for Crew Health and Performance Exploration Analog. Anyway, the project that is now being funded as an SBIR will probably be based on laser sintering or some other technique involving melting of the regolith, rather than some form of cement like that used in 3D printing of houses or used in that Mars Dune Alpha project. This research is part of an overall NASA project called MMPACT, which stands for Moon to Mars Planetary Autonomous Construction Technology. It's going to include testing on the lunar surface using robotic landers, maybe in 2028. Interestingly, the Chinese have similar plans, including testing of 3D printing from a lunar lander in 2028. We reported on the Mars Dune Alpha project back in October 2021, so this seemed like a good time for a quick update on its status. The inset picture to the left of the slide is from the 2021 news story. The 3D printed habitat covers 1,700 square feet for use by a crew of 4 people. In its partially completed state, you can see the crew quarters and various other rooms. That's in the picture on the lower left side there. The 3D printer is on rails on the outside edges of the building, with the printing arm overhead between the rails. It's visible in the right corner of that lower left picture. The printing nozzle can be seen in the picture at the bottom center. The printing material is called lavacrete, which is Portland cement mixed with crushed lava. For this project, red dye was also added to make it seem more Martian. Water is used to make the lavacrete, just like it's used on Earth. The CHAPEA missions seem fairly conventional and similar to many other Mars analog missions. They're going to focus on physical operations, human behavior, and food systems. What is new is the 3D printing for the habitat. So, where does the project stand? The construction was completed in May of 2022. It was built inside of Building 220 at Johnson Space Center. The entire structure was not done using 3D printing. For instance, the roof was cast in pieces outside and put in place with cranes. Several papers have been published about this project. Many 3D printing issues for Mars or the Moon were identified and some were addressed, but few could be tested because conditions inside an air-conditioned building at atmospheric pressure don't match the severe environment of Mars or the Moon. Issues identified included one, integrating parts brought in from Earth, in particular things like airlocks, windows, power lines, and so on. A major issue, of course, will be pressurization and sealing. These issues were considered, although not tested, in this project. Mars pressure is 1% of Earth's, and of course, the Moon is even less than that. They couldn't test for that. Thermal expansion and contraction would be a big concern in any of these projects. For instance, on Mars, maybe on a warm summer day at the equator, you might get 60 degrees, but then it could still drop down to 100 below at night, and maybe up to another 100 degrees lower at the poles. The Moon would be even worse, of course. They did test out building special joints to avoid cracks, and they knew that would be needed. So techniques for that were included in the building, but of course the testing of their impact wasn't really possible. It was also suggested that structural reinforcement would be helpful. Another issue, of course, would be vacuum and cold conditions during the construction, which they couldn't really reproduce. One issue not really considered is the chemicals that are actually in the regolith. Mars regolith, in particular, has poisonous perchlorates and all kinds of other differences from Portland cement. So there's issues of human health as well as what chemical reactions will actually occur. Another issue is the use of water. Of course, water was used for this concrete. It was basically Portland cement. Besides the likely difficulty in getting the water on Mars, there's also the issue that other studies had shown that rapid water evaporation under high vacuum could lead to very porous concrete, not really strong enough to be useful. In general, other work that has been done as part of this M-Impact NASA project had led to the conclusion that using water for construction on Mars or the Moon was pretty unlikely. The only possible chemical binder left in contention is one based on calcium, sulfur, and aluminum. Those weren't tested here, but that's been part of the other research by NASA. So instead, some form of laser sintering, or in general, some way of melting all or parts of the regolith would probably end up having to be used. The estimated mission start date has also slipped. It is now set for the summer of 2023. So, I hope this gives an idea of some research into 3D printing for construction on the Moon or Mars. The current manned exploration program can't assume this will all work in time for early explorers, so they don't include it in those plans. And the same has been true for other in situ resource utilization. This is just one example of that. But long term, for significant expansion into space, it is obvious that we need to learn to use local materials whenever possible.